Beta, welcome to Maheshwari chemistry classes. These are some important questions for first year purpose. So listen carefully. Every time I am thinking about first year students, but it is not possible. So anyway, listen beta. This is the first and foremost important question LAQ. Bohr's atomic theory. Write the postulates of Bohr's model of hydrogen atom. Explain various lines in hydrogen spectrum. Okay, simple. Bohr's atomic model with hydrogen spectrum. This is the first important LAQ in first year chemistry. Okay, so Bohr's atomic theory, it was proposed by Niels Bohr. What is the name of scientist beta? Niels Bohr. First we have to imagine center of the atom, that is the nucleus. Around the nucleus electrons are involved in a circular path. That path is called as orbit. That orbit's purpose we have to give N, L, M and OP like that. Okay, so R 1 2 3 4 5 like that. So when electrons revolve around the nucleus of an atom, the circular path is known as orbit or shell. Okay, so here energy is fixed, energy not changes in these shells. That is why those are also called as stationary states or stationary levels. Those are indicated with the 1 2 3 4 5 6 so on or K, L, M and O. The energy, when these are in this orbit, energy not changes, but when they want to jump from higher to lower or lower to higher like this, then only for example the electron may jumps from higher energy level to lower energy level. Energy emits outside. If it want to jump from lower energy level to higher energy level, it will absorb the energy. Okay, so for that time delta E equals to E2 minus E1, that is H nu equals to the H nu. Delta E equals to H nu. H nothing but Planck constant. Its value is 6.6256 into 10 power minus 27 erg second. It is erg second only, not erg per second. Minus 27 erg second. Okay, so here H equals to 6.6256 into minus 10 power minus 27 erg second, or else H equals to 6.6256 into 10 power minus 34 joule second. Nu is the frequency of radiation. Okay, so next the angular momentum of an electron, integral multiple of h by 2 pi. Here why we have to take angular momentum means electron revolving in a circular path means it may with radius it have in moment, nothing but mass have, velocity have, and it contains some of the radius. That is why we have to take MVR, angular momentum. Okay, MV is momentum, angle mentioned, that is R. Radius is there, na? That is why MVR equals to NH by 2 pi. M mass of the electron, V velocity of the electron, R radius of the given orbit, N1 2 3 4 already you know very well. Okay, the force of attraction. Next point, angular momentum. After you have to write how it is stable. The force of attraction between nucleus and the electron balanced by the centrifugal force. Okay, exerted by the electron. Okay, how electron is attracted towards nucleus, same as is outside energy is there. Centrifugal force and centripetal force is there. When both are equal, it must be stable. Okay, so this is the fifth point. Next, hydrogen spectrum, nothing but line spectra in atom. Which atom? Hydrogen atom. When hydrogen gas is passed through electric discharge, okay, so that electric discharge tube, when hydrogen gas is passed, so they may absorb, okay, different amounts of energies excited into higher energy level. Okay, so that time, look at this beta, these emissions of spectral lines are there. One is a Lyman series, Baumann series, Paschen series, bracket series, Fund series. Another also there, but according to the IPE, these are enough. 5 are enough. Lyman, Baumann, Paschen, bracket, Fund. Lyman N1 value 1, 2, 3, 4, 5. Lyman 1, Baumann 2, Paschen 3, bracket 4, Fund 5. Like that you have to write. After number is N2. Okay, 1 after 2, 3, 2 after 3, 4, 3 after 4, 5, 4 after 5, 6, 5 after 6, 7. Like that you have to remember. Next here, 3 regions we have. One is the ultraviolet UV region, another visible region, another one is the IR region. In IR also we have 3 variations: near, middle, far. Okay, UV, visible and IR. Okay, near, middle, far. Okay, so for this we have to draw the diagram like this. This is the diagram. So you have to take 7, N7 to N1. Okay, in some books n6 also there, but you have to draw n to 7 to n1. It must be good. 7 to 1, 6 to 1, 5 to 1, 4 to 1, 3 to 1, 2 to 1, like that we have to draw. Later we have to leave the first level, next second, up to the second level. Okay, so this is the Lyman series. Up to the second level is Balmer series. Up to the third level is the Fashion series. Up to the fourth level is the Brackett series. Up to the fifth level is the Fund series. Like this we have to draw the diagram. Lyman UV region, Balmer visible region, Passion near IR, Brackett middle IR, Fund far IR region. Next we have to write the Rydberg equation. Okay, the wavelength of these lines can be given by the Rydberg equation. What we are finding? Wavelength. With the help of which equation? Rydberg equation. Nu bar equals to 1 by lambda RH into 1 by n1 square minus 1 by n2 square. This is the equation, remember carefully. And RH nothing but Rydberg constant. That value is 1,09,677 centimeter inverse. For academic structure purpose, anyone want complete Telugu explanation, another special video is there. Complete chapter is also available. So, but these LAQ purpose, this much theory is enough. Once check this better. Yes, like this you have to write. Okay, after the completion of this, you write this angular momentum. Later, how it is stabilized. After that, hydrogen spectrum related table after diagram after Rydberg equation. You may get 8 marks. Okay, and many times repeated question. This carbon contains 12.8% carbon, 2% hydrogen, 85% bromine. The molecular weight of the compound 187.9. Then calculate means we have to draw this table. So here we have to find the empirical formula. Okay, serial number, element, mass percentage, atomic weight, relative number of moles, simple ratio, simple hole ratio, carbon, hydrogen, bromine, carbon mass 12.8, hydrogen 2.1, bromine 85.1. Already in question they given this data, so just we have to substitute that one. Next, atomic weight we have to write carbon 12, hydrogen 1, bromine purpose 8. Next, what we have to do beta? These mass percentage by these atomic weight, that is a relative mass. Okay, 12.8 by 12. Next 2.1 by 1, 85.1 by 80. If we did now 1.06, 2.1, 1.06 will come. Next we have to do the simple ratio. Simple ratio, how can we do? Individual values by smallest value. Individual value, what is that beta? This is the 1.06. Smallest value also 1.06. Okay, 1.06 by 1.06, that is the 1. Next individual value here 2.1. 2.1 by smallest value 1.06. Then we get the 1.98. Next same as it is. Here individual value also 1.06. Smallest value also 1.06. Then we can get the 1. Okay, this is a small ratio. So how can we get 1? Nothing but 1, same as it is. 1.9 nothing but we have to consider as a 2. Next another 1. Nothing but carbon purpose 1, hydrogens 2, bromine 1. So CH2 Br, this is the empirical formula. Now we have to write the formula weight. Hydrogen purpose, carbon purpose 12, hydrogen 2 atoms are there, that is by 2, bromine 1 is there, that is by 80. Total 94 formula weight. Then we have to write the N number. N number purpose, molecular weight of the compound by empirical formula. Molecular weight of the compound already given in data, 187.9, that is 187.9 by 94. Then you may get approximately 1.99, nothing but the value is 2. Then we have to consider as N value 2. Already you know the empirical formula, CH2Br taken N, right? So here CH2Br taken N, nothing but CH2Br taken 2. Finally we get a C2H4Br2. Sorry beta, writing is not good. Already it is too late. Now the time is 1:30 night. So please try to understand. It may be like a SAQ. Okay. Next, one more important LAQ. Okay. So that is write about quantum numbers. ZZ and very important. Okay. Listen better. Quantum numbers, how many? 4 quantum numbers we have. Okay. What are those? Principal quantum number, Rajagopal quantum number, magnetic quantum number, and spin quantum number. Okay. So quantum number explains about the electron, electron, where it is present. Okay, complete information given by these quantum numbers. Okay, what is the shape and how, which type of spin is present, how much the energy, complete information given by these quantum numbers. Here principal quantum number was proposed by Bohr, azimuthal quantum number Sommerfeld, magnetic quantum number Landé, spin quantum number Uhlenbeck and Gaudsmit. Principal quantum number indicated with the small n, azimuthal quantum number indicated with the small l, magnetic quantum number with small m. Here spin quantum number, yes. In some books, magnetic quantum number purpose ml is also there. Spin quantum number purpose ms is also there. That is your wish. Both are also correct. Next, principal quantum number determines the orbit numbers. N equals 1, 2, 3, k, l, m, n, like that. And principal quantum number determine the energy of electron in an orbit. Okay. Next, maximum number of electrons present in orbit is 2n square. Okay. When n value increases, energy also increases. This is about the principal quantum number. Okay. Next, you have to learn about the azimuthal quantum number. Azimuthal quantum number, who proposed beta? Sommerfeld, indicated with the L. What explains? It explains about the orbitals, nothing but subshells, s, p, d, f. Beta principal quantum number, n is orbit, L is orbital, L is orbital, n is orbit. Okay, in orbit, orbitals present. Those are the s, p, d, f. When L value 0, s orbital. When L value 1, that is a p orbital. L2, d orbital. L3, f orbital. Okay, so mainly it explains about azimuthal quantum number, explains about the shape of the orbital. L equals to n minus 1. Okay, so we have to write like this: s orbital in spherical shape, p orbital dumbbell shape, d orbital double dumbbell shape, f orbital four-folded or not founded. Okay, next azimuthal quantum number purpose, subshells formula. Okay, 2 into 2l plus 1, and energy of any electron depends on the n plus l value. Next, magnetic quantum number, it explained by the Landé. Okay, determine the orientation of subshell. Okay, if you take a graph beta, so center point is 0, left side is negative and right side is a positive. Okay, how much it is showing the orientation. Okay, so that is explained by the magnetic quantum number. Okay, so that is why minus L, 0, plus L values. It explains about the Zeeman effect, nothing but in magnetic field how the lines are splitted. That magnetic quantum number m equals to 2l plus 1. It degenerate orbital purpose, same E value. If L equals to 1, then m value minus 1, 0, plus 1. This is about the magnetic quantum number. Magnetic quantum number main duty, it determine the orientation of subshell. Okay, main formula m equals to 2l plus 1. Next, spin quantum number, who was proposed beta? Uhlenbeck and Gaudsmit. In some books it is different, but it is Uhlenbeck and Gaudsmit only correct. Okay, it determines the spin and rotation of direction of the electron on its axis during